All right, here we go. We've got a question about spinning spheres, and we're told that they have the same rotational kinetic energy, and we want to know something about their angular momentum. As usual, hit pause, try the question, press play, and let's see if we agree. All right, so in this kind of question, I do find that some students are unsure where to start. What we're going to look for is how can we link the quantities which are being stated here. We've got kinetic energy, rotational kinetic energy I should say, moment of inertia, and angular momentum. Now, I'm going to put up an equation here for kinetic energy. Hopefully, this is the one that students know very well, half I omega squared. Okay, where we've got, just like our half mv squared, we've got I playing the role of mass and omega playing the role of the speed. Now there's another equation which we can use, which is L squared over 2I. Now this is just like in our translational motion, we can have P squared over 2M. For rotational kinetic energy, we can have L squared over 2I. Okay, now I'll take it as a given that you might know this one. However, if you're not sure, please do take some time to check that that makes sense to you. Okay, we're going to use that equation because now we have an equation which relates kinetic energy, angular momentum, which is in the question here, and moment of inertia. So let's rearrange firstly. We can say here that our angular momentum is simply the square root of 2 times the moment of inertia times the kinetic energy. What we want to do is find Lx over Ly. So what we're going to do now is just take those ratios. Root 2 Ix Ek, root 2 2Iy Ek, and we know that the kinetic energies are constant. The 2 is also a constant. So we're left with a nice ratio, which is square root of Ix over Iy, which is the answer A. So like I say, I think an area of difficulty here may be just this identification that there are multiple equations for some of the quantities we use. Just like for kinetic energy in translational sense, half mv squared, we also have p squared over 2m. For rotational energy, we have half I omega squared and also L squared over 2I, and you could use either of those equations to come to this answer. However, this is the most direct one.